Okay, we're now going to look at the power rule for logarithms. Power rule allows us to bring the exponent down and put it in front of the logarithm in order to solve. So we want to find out how many digits 3 to the 5,000th power has. So if we take the log of 3 to the 5,000th, the power rule allows us to bring that exponent and write it down in front of the log. So we have 5,000 times the log of 3. Now if you pull out your calculator, we have the log button, which is down here next to the 7. So if we do log of 3, we get 0.47712125547. And multiply it by 5,000. Gives us 2,385.606274. Which is approximately 2,386. Now, suppose y is a number such that log base 7 of y equals 86, or 8.6. Evaluate log base 7 of square root of y. So this is log base 7 of square root of y. Well, remember, we can write the square root as an exponent, a fractional exponent of 1/2. Then this power rule allows us to bring the 1/2 in front. So we have 1/2 log base 7 of y. Well, we're told that log base 7 of y is 8.6. So this would be 1/2 of 8.6, which is 4.3. So log base 7 of square root of y is 4.3. Suppose a cat skeleton found in an old well has a ratio of carbon-14 to carbon-12 that is 61% of the corresponding ratio for living organisms. Approximately how long ago did the cat die? Well, we have to figure this one out. There's a table in the textbook that tells you what the half-life is, because it's the half-life is what we're concerned with. And the half-life for carbon-14 is 5,730 years. So that means that 5,730 years after the cat died, half of the carbon-14 that was in the bones when the cat died is gone. Or conversely, half of it is still there. So our formula is A of t equals a sub 0 times 2 to the negative t over h, where h is the half-life. Now, we don't know what a sub 0 is, but we do have the ratio. We know that a of t over a sub 0 is 0.61. So then 0.61 equals 2 to the negative t over 5,730. So if we take the log of both sides, we have the log 0.61 equals the log of 2 to the negative t over 5,730. Well, the property allows us to bring that exponent in front. So we have log of 0.61 equals negative t over 5,730 times the log of 2. Well, we want to find out what t is. So the first thing we're going to do is multiply by 5,730. So 5,730 times the log of 0.61 equals negative t times the log of 2. We want to get t by itself. So we have 5,730 log of 0.61 divided by negative log of 2 equals t. So now all we have to do is put this in our calculator, and we will find out what t is. So 5,730 times the log of 0.61 divided by the negative log of 2 tells us that t is equal to 4,086.1710 years. So approximately how long ago did the cat die? 4,086.1710 years. Okay, we want to evaluate log base 2 of 73.9. In other words, what power of 2 gives us 73.9? This is where we use the change of base formula. The change of base formula says the log base b of y is the log of y over the log of b. So log base 2 of 73.9 is the log of 73.9 divided by the log of 2. So we have the log 73.9 divided by the log of 2, which gives us 6.2075. And it makes sense that it's between 6 and 7 because 2 to the 6th is 64 and 2 to the 7th is 128. So this is between 64 and 128, and it's closer to 64. Now you can check this. And remember this 6.2075 is rounded. So if we do 2 to the 6.2075, so 2 to the 6.2075 gives us 73.8999, which is approximately 73.9. Okay, that's it for working with the power rule for logarithms.